The fork join operator lets you create an observable from a variable number of other observables you supply. On subscription, fork join subscribes to all inner observables. After all inner observables have completed, fork join emits the last emitted value from each inner observable as an array. For instance, in this example, observable 1 emits a value, then completes. Observable 2 then emits the value A, then the value B, and then completes. At this point, both supplied observables have completed, so fork join emits the last emitted value from each, which is 1 and B, and then completes. Let's take a look at fork join's behavior in code and check out a common use case. To start, I created an observable of numbers that emits 1, 2, and 3, and an observable of letters that emits A, B, and C. Let's combine these with fork join to see how it works. So let's go ahead and add the fork join import now from RxJS. Now let's go ahead and create an observable with fork join. Like merge, concat, and combine latest, fork join accepts any number of observables as arguments. For this example, let's just supply our numbers and letters observables that we created above. Now let's go ahead and subscribe, just logging the result to the console. And we'll save and check this out. Fork join emits the last emitted value from each observable as an array on completion. So in this case, the last value emitted from the letters observable is C, and the numbers observable is 3. To confirm nothing happens until both observables complete, let's actually introduce an artificial delay using the delay operator. So let's go ahead and add the import for delay now from rxjs/operators. And on our letters observable we are passing to fork join, let's delay the emitted value by 3 seconds. So when we save now, we can see nothing is emitted by fork join until 3 seconds pass, at which point the letters observable emits its last value and completes, and fork join emits both values. If you're using RxJS 6.5 or greater, you can also supply and receive values from fork join as an object map. For instance, instead of passing a comma-separated list of observables to fork join, we could instead wrap this in an object. We could then give keys to the observables we are supplying, so let's name the first property numbers, and the second property letters. If you invoke fork join in this manner, it will emit an object rather than an array, matching the properties you supplied. So, in this case, we see fork join emitted an object with the numbers and letters keys containing the values from our numbers and letters observables. Either approach works fine, but I personally prefer consuming an object rather than matching the response based on index. So now that we know how fork join works, let's take a look at its most common use case. The vast majority of time I'm using fork join in my applications, I'm using it to create an observable for multiple HTTP requests, generally to retrieve data from several endpoints on page load. If you have ever used promise.all, you can think of the common use cases for fork join in much the same manner. In this example, I have already imported the fork join and AJAX operators. I also have a constant for the base GitHub API URL. Let's use fork join to fire off multiple requests to retrieve user and repo information, logging the emitted results to the console. So let's call fork join, and for this example, let's pass in an object map of AJAX observables. We'll name the first property user, and use the ajax.getJSON method to create our AJAX observable. For the URL, let's use a string literal to combine the base API URL with the URL to request the ReactiveX user info. So this is just /users/ReactiveX. Next, let's create a second property called repo, and we'll just copy down our AJAX observable from above, appending /repos to the end. Finally, let's subscribe and log the result to the console. When we save, we can see fork join emits the response from our two AJAX observables as an object, matching the keys we supplied. In your applications, you could then use this data to take whatever action needed based on the combination of the emissions from these observables. To recap, fork join subscribes to all observables you supply on subscription, emitting the last emitted value of each once all inner observables complete. Fork join will either emit these values as an array or a dictionary, depending on how it is invoked.